This is slope part 2, lesson 3.19, and we are going to continue with our slope lesson. We're going to first talk about the slope of parallel lines. Okay, parallel lines, as we know from previous lessons, are lines that never cross. Okay, so therefore they are going to have the same exact slope. So for example, if you're given that line A is parallel to line B, and we know that the slope of line A is 3/4, then the slope of line B also has to be 3/4. So that one's pretty easy. Given parallel lines, the slope always has to be the exact same. For perpendicular lines, okay, remember perpendicular lines are lines that cross and they form a right angle, which is 90 degrees. Okay, so therefore lines that have no slope or zero slope, which is this horizontal line right here, and lines that have an undefined slope, which is this vertical line right here, they form perpendicular lines. In order to find the slope of perpendicular lines, given the slope of one of the lines, you are going to find the opposite reciprocals, okay? So if you're given the slope of a line is 2/3, then the slope of the line perpendicular would be -3/2. Okay, when we're talking about opposite, we're talking about the sign of the slope. So for this one, 2/3, the sign is positive. So that's why we know that the new slope is going to have to be negative. Okay, reciprocals, remember from previous maths, reciprocals are when we flip the two numbers. So the reciprocal of 2/3 is going to be 3/2. So therefore, a line that's perpendicular to 2/3 is -3/2. So in order to find the slope of the line, for example, that's perpendicular to -1/2, okay, it is negative, so now our new slope is going to be positive. Okay, we have 1/2, so our new slope is going to be 2/1. Okay, so, and again, remember, we don't write the positive. Okay, so we would just say 2/1 or 2. Either one of those is fine. For 8/7, okay, this one is a positive slope, so we're going to make it negative. 8/7, the reciprocal then is going to be 7/8. So our answer for that one is -7/8. For 3/5, okay, this is positive, so we're going to make it negative, and then we're going to flip our numbers. So -5/3. And for this one, it's negative, so our new slope is going to be positive, okay, and we're going to flip these two around, so it's going to be positive 11/7. The mid-segment of a line is the point that divides the length of the line in half, okay? So if we're given 2 points, okay, the mid-segment is going to be the halfway point, okay, in between those two endpoints, all right? In order to find that, we're given the formula x1 plus x2 divided by 2 is going to give you your x point. Y1 plus Y2 divided by 2 is going to give you your Y point. So for this one, our X1 is 1, our X2 is 6, our Y1 is 2, and our Y2 is 4. So X1 plus X2 is going to be 1 plus 6 divided by 2. And then our Y1 plus Y2 is going to be 2 plus 4, and it's going to be divided by 2. So now we have 7/2 and 6/2, which actually comes down to 3.5, 3 as our point. And if we looked at that, actually, if we go over here and look, okay, if we go over 1, 2, 3.5 and up 3, if we notice, that really does kind of mark the halfway point. See, you can see that it's halfway in between. On this one right here, we're going to determine whether the segments of a line are parallel, perpendicular, or neither. So remember, when we're determining this, we're talking about the slopes of the line. So we're going to have to find the slope of the line first because we're given the endpoints. So for the first segment, we're given the endpoints 4, 8, and 6, 3. Now remember, when we're given 2 points, in order to find slope, it's the change in the y over the change in the x. Okay, so for this one, okay, that's, oh, and the formula, remember, change in y, so y2 minus y1 over change in x, which is x2 minus x1. So we're going to say x1, y1, x2, y2. Okay, so y2, 3 minus 8 is going to be then 6 minus 4. So 3 minus 8 is -5, and 6 minus 4 is 2. So the slope of line 1 is -5 over 2. For the second segment, we're given -1, 5, and -6, 3. So again, we're going to label our points x1, y1, x2, y2. And we're going to plug in our formula. Y2 is 3 minus y1 is 5. Oh. X2 is -6 minus x1, which is a -1. So this is actually 3 minus 5 over -6 plus 1. So 3 minus 5 is, sorry, is that, oh, 3 minus 5 is -2, okay, and -6 plus 1 is a -5. So that's actually, negative over a negative is a positive. So our slope for this one is 2 over 5. So if we're comparing these slopes, okay, parallel, remember, parallel means that they have the same slope. So looking here, we know that's not the same. Perpendicular is the opposite reciprocal. So if we look at this one, it's a negative slope. This one's positive, so that's a check. Then the reciprocal, 5 over 2, would be 2 over 5. So positive 2 over 5. So these lines are, in fact, perpendicular. On this one, it says, what is the slope of a line that is perpendicular if the coordinates of A are -2, 1, and the coordinates of B are 1, -3? Okay, so for this one, all right, what we're given 2 points. So again, we're going to find the slope of the line first before we can say what slope is perpendicular. Okay, so again, x1, y1, x2, y2. So we're going to plug our numbers in. Y2 is -3 minus y1, which is 1. Okay, x2 is 1 minus the -2, right? So that gives us -3 minus 1 over 1 plus 2. -3 minus 1 is a -4, and 1 plus 2 is 3. So the slope of this line is -4 over 3. So in order to find the perpendicular line, we want to find the opposite, right? So we're talking about the sign. This one's negative, so we know our new slope is going to be positive, and the reciprocal of 4 over 3 is 3 over 4. So my new line is going to have a slope of 3/4, and it will be perpendicular. Okay, the vertices of a square are A, 3, 4, B, 5, 4, C, 5, 2, and D, 3, 2. The diagonals of the square intersect at their midpoints, and we want to know what are the coordinates of the midpoint where the diagonals intersect. So just to kind of make a picture right here, okay, we're given 4 points of a square. Okay, we're given A, 1, 2, 3, 1, 2, 3, 4. This is A. Then B, 2, 3, 4, 5, 4. C is 5, 2. And D is 3, 2. Okay, so we're finding, what we're wanting to do is find where the diagonals intersect here in the middle. Okay, so on this, what we're going to find, all we need to do is find the midpoint between line AC and the midpoint between line DB. So remember, our formula is x1 plus x2 divided by 2 for the x point, and y1 plus y2 divided by 2 for the y point. Okay, so for line AC, we use these points. So A is going to be x1, y1. C is going to be x2, y2. Okay, so x1 plus y1 is 3 plus 5 divided by 2. Y1 plus y2 is 4 plus 2 divided by 2. 3 plus 5 is 8 over 2. Okay, 8 divided by 2 is 4. 4 plus 2 is 6 divided by 2 is 3. Okay, so we know the midpoint of line AC is 4, 3. So we're assuming that's where they intersect, but it's good to check your work, all right, and go and also find the midpoint of line BD. Okay, so now for this one, we're now going to name this x1, y1. We're going to name this x2, y2. Okay, so x1 plus y1, 5 plus 3 divided by 2, and y1 plus y2, 4 plus 2 divided by 2. Okay, so 5 plus 3 is 8 divided by 2 is 4. 4 plus 2 is 6 divided by 2 is 3. Okay, so the coordinates of the midpoint where the diagonals intersect then is going to be 4, 3. And that is the end of slope part 2.